Boyle's law states that when a sample of gas is compressed at a constant temperature, the product of the pressure and the volume remains constant. PV is equal to C. In part A, what we want to be able to do is find the rate of change of volume with respect to pressure. Okay, so the first thing is we're going to take a look at the formula, which is PV, which is equal to C. And what we want to do is we want to solve for the volume because it's asking us to find the rate of change of volume with respect to pressure. So in order to solve for V, we're going to divide both sides by P. So we're going to get V, which is equal to C over P. Okay, but then since we're going to find the rate of change, what we want to do is we want to make this a little bit easier on us. So we're going to rewrite this as V, which is equal to Cp to the -1 power. So now what we're going to do is now we want to be able to find the derivative of V with respect to P. So if we want to find the derivative of V with respect to P, well, if we take a look at here, to find the derivative of that function, we're going to take a -C times P, and that's going to be to the -2nd power. So if we want to rewrite this without negative exponents, so dV over dP is going to equal -C over P squared. And so therefore this is the rate of change of volume with respect to pressure. Okay, now in part B it's saying a sample of gas is in a container at low pressure and is steadily compressed at constant temperature for 10 minutes. Is the volume decreasing more rapidly at the beginning or the end of 10 minutes, and then explain? So we know that from the given information that steadily compressed implies that the pressure is increasing. And so what do we know? We know that if the derivative of V with respect to P is approaching 0 as pressure increases, so therefore as pressure increases more rapidly in the beginning, so the next part, in part C, it says prove that the isothermal compressibility, see in example 5, is given by beta, which is equal to 1 over P. Okay, so from example 5, we know that the isothermal compressibility beta is equal to -1 over V times dV over dP. Okay, so what do we know about dV over dP? Well, up here we know that dV over dP is equal to -C over P squared. So we can rewrite this as beta, which is equal to -1 over V times -C over P squared. So when we multiply this out, we get a negative times a negative, which is a positive C over VP squared. Or we can say this is C over VP squared. And now what we want to do is let's go back to when we have at the beginning where PV is equal to C, right? Okay, this is the same thing as saying VP is equal to C, correct? So that means that these two are equal to each other. They're equivalent. So down here, we can rewrite this as C over VP times P. And what do we know? We know that VP is equal to C, so we can substitute that VP to be C. And so therefore, we get C over C times P. And we know that C divided by C is going to give us 1. So therefore, we have beta, which is equal to 1 over P, which is what we wanted to prove.